Hi, in our last video, we discussed about the concept of the garbage collection in Python, how Python handles the garbage collection. In this video, we are going to see a demonstration part of the concept of garbaging the object. If you look at this demonstration, you can understand that how an object is eligible for garbaging, and this is an automated functionality by Python, as we have already discussed in our earlier session. Now we are going to discuss by declaring a variable called x, more similar to the slides that we have discussed in the previous tutorial. The x value is going to be 3.14. Now what exactly happens when I execute this code? When I execute this code, the interpreter is going to create an object, and the object is going to hold a value of 3.14, and that object is going to be referred by an symbolic name called x. So let's hold that object here. I have an object, a float type of object, which is 3.14, and this is a float object, and it's going to be referred by the symbolic name called x. So x is pointing to this object. Later, what I'm going to do is I'm going to declare another variable called y, and y is going to point to x. So what exactly happens in this expression? The x value is not stored in y, rather x reference is referred by y. How do we understand this? As we already discussed more in detail about the traceability of ID of an object in the earlier tutorials, let's recall that expression in order to identify the ID of these two objects. Since the reference is exchanged here, when I try to print the ID of x, the ID of x is going to be this, and similarly when I'm going to print the ID of y, it's going to be the same. So what exactly happens here then is, we have declared another variable, a symbolic name called y, and now the y is pointing to the same object of float. So now when I'm pointing this object 3.14, it means that there are two symbolic names pointing to the same object. That is the understanding. Right now the count of the reference to this object is 2. So there are two references. One is your x, another one is your y, which is 2. So totally there are two variables which are referencing to this particular object. When the object will be garbaged? Only when the reference count comes down to 0. When the reference comes down to 0, the reference count comes down to 0, then the object is eligible for garbaging. Now, how do we understand whether the object is eligible for garbaging or not? Let's see another example. I'm going to disconnect the reference of y to x by carrying the same variable name and assigning a value of true, which is a new object that's going to be created when I'm going to execute this code. Now when I execute this, you can notice that the IDs are different right now because there is a new object that gets created in the memory, and this object is going to carry a value of true, and the reference to this object is via the symbolic name called y, and the y is going to point to this object. So is that a new symbolic name? Not exactly. So how it's going to be done? Instead of creating a new symbolic name, now what the interpreter does is, it will disconnect the connectivity of y to this 3.14 object, the float object, to the connectivity of the Boolean object. So y is going to be disconnected from 3.14, and now the y is going to be connected to the Boolean object and the value is true. Now if you notice here, the count of this particular float object is going to be 1, because before it was 2, now it got reduced to 1. But still the object is there in the memory because there is one variable, a symbolic name is still pointing to this float. The count is not coming down to 0. Okay. Then this new object, which is a Boolean object, have been pointed by this variable called y, and the y reference to this object will bring a number of count as 1. Later what I am going to do is I am going to create a new variable, entirely a new variable name, and here I am going to assign a string called bird. So by this way, now what happens is when I execute this is it's going to create a new object, and the object is going to carry a value of the string called bird. And I have another symbolic name called z, where the z is going to have a reference mapped to this object, and here again the count of the reference is going to be 1. So all the objects are now currently holding one reference in it respectively. But which object is now eligible for garbage collection? That's the question that we have. None of the objects are currently eligible for garbage collection because all the objects are currently holded by the respective references. But in order to make one of the object to be garbage collected, we need to bring the count down to 0. That's what we have learnt in the theoretical understanding of the previous lecture. So we have to bring down this count of reference to be 0. So what I'm going to do for that is I'm going to consider this Boolean object to become eligible for garbage collection. So in order to do that, initially now the y is pointing to that Boolean object, where now the same y variable is going to hold the reference of z. Now the z and y will have the same ID. If you notice here, the z and y will have the same ID. Why? Because the y's reference is now pointed to the z object. So typically now if I disconnect this y's reference from the Boolean object and create a reference to the z object, that is your bird object, which is a string object. Now here this object will come to a count of 2. So we are going to have 2 references which has been counted. So I'm going to use 2 here. But if you notice, this object is now completely independent. It's not dependent by any of the variable. So the count is going to become 0. Instead of 1, previously it was 1 because y was referring to it. Now no variable is referred to this particular object, so the count comes to 0. When the count comes to 0, this particular object is now eligible for garbage collection. So it's going to be garbaged. So once it is garbaged, then this particular memory or the data can never be accessed at any point of time in your application. Now what happens to this 3.14, which is a float value? You still have one reference, which is x. X is still pointing. So from the beginning, the floating value is being pointed by x. So x is still pointing to it, and the bird is pointed by z, and also it is pointed by another symbolic name called y. But intermittently, the object which we created, a Boolean object which was pointed by y, got disconnected, and solely this object became independent, or it became orphaned. When the object becomes orphaned, then that particular object state, the orphan state of that object, is actually eligible for moving into the garbage state. So Python interpreter will deal with all these garbage collection mechanisms. It has its own inbuilt garbaging algorithm which will work accordingly and keep tracking the number of references that's been referred by that object. there might be 3 or 4 variables which might point to the same object. So let's say I have A, I have B, I have C. All these are the variables which are pointing to this particular string object. Now what it means is the total number of count comes to 5. Y, B, Z, A and C. So the total count for this particular reference is 5. Now when all these references are disconnected and when the count comes to 0, then the string object is actually eligible for garbage collection because the object becomes orphaned. But looking at this particular scenario, the only object that is eligible for garbage collection is the Boolean object which we have created, because there are 0 reference variable for it or 0 reference symbolic names are available. So this object is orphaned right now and this object is eligible for garbage collection. So this is how we can understand the implementation of garbage collection in Python. We'll see the next concept in the next tutorial. Thank you.